Welcome back to the channel in part 2 of our Introduction to SQL course hosted by Datacamp. Today we'll start where we left off. We finished relational databases overview last time, and today we're going to be talking about querying. So let's jump on in, continue chapter.
Welcome back. Now that we understand how data is organized in databases, we can begin drawing insights using SQL queries. Recall from the last chapter that SQL is used to answer questions both within and across relational database tables. In the library database, we might use SQL to find which books James checked out from the library in 2022. In an HR database, we could query salaries for employees in marketing and accounting to determine whether pay across departments is comparable. In many organizations, SQL is used as a complement to other tools such as spreadsheet applications. If the data we're interested in can fit in a spreadsheet and does not have many relationships to other data of interest, we can analyze it in a spreadsheet. But for sprawling and diverse data, such as the data related to a retail platform, organizing the data in a database is best. Then, we use SQL queries to uncover trends in website traffic, customer reviews, and product sales. Which products had the highest sales last week? Which products get the worst review scores from customers? How did website traffic change when a feature was introduced? SQL shines when an organization has lots of data with complex relationships. Let's write our first SQL code. To do that, we will need to learn a few keywords. Keywords are reserved words used to indicate what operation we'd like our code to perform. The two most common keywords are select and from. Perhaps we'd like a list of every patron our library has. The select keyword indicates which fields should be selected. In this case, the name field. The from keyword indicates the table in which these fields are located. In this case, the patrons table. Let's put these parts together. Here's how the query should be written. The select statement appears first, followed on the next line by the from statement. It's best practice to end the query with a semicolon to indicate that the query is complete. We also capitalize keywords while keeping table and field names all lowercase. Now let's take a look at the results of our query, often called a result set. The result set lists all patron names, just as we had hoped. Note that we have not changed our database by writing this query. The tables, including the patrons table, are exactly the same as before we wrote the query. In order to share our results, we can save the SQL code we have written so that our collaborators can use it to query the database themselves. We'll cover saving queries in a later lesson. To select multiple fields, we can list multiple field names after the select keyword, separated by commas. For example, to select card number and name, we'd list both field names in the order we'd like them to appear in our result set. Notice that this does not have to match the order the fields are presented in the table. Listing name before card num means that name appears first in the results. As you might expect, we can select 3 fields, such as name, card num, and total fine, by listing all 3 field names after the select keyword and separating them with commas. What if we'd like to select all 4 fields in the patrons table? We could list out the 4 field names after the select statement, but there's an even easier way. We can tell SQL to select all fields using an asterisk in place of the 4 field names. Let's get some hands-on experience writing our own queries. In this chapter, you'll work with the books table introduced in the previous chapter, which lists all 350 books that our little library owns.
For our first question, SQL strengths, which of the following scenario best describes a situation in which using SQL would be helpful? 1. All data needed to answer the business question is presented in a spreadsheet, and no complicated relationships exist between data points. This one is not true. Large amounts of data about many different but related areas of business are housed in a relational database. Potentially, probably. The data needs to answer the business question doesn't exist yet. So definitely 2, submit answer. We're right. Developing SQL style. Recall from the video that it's important to pay attention to the formatting of SQL queries in order to make them readable. This is especially helpful as you learn more keywords and your queries get longer. In this exercise, you'll review the below query about the patrons table. This code will run properly, but it's messy and hard to read. Your task is to determine which edits are appropriate to improve the query so that it follows best practice for SQL styling. So let's look at our query here. A few things immediately jump out. We're missing a semicolon. These fields should be lowercase, and then our select and from both need to be capitalized. But let's see what our suggestions are. So capitalized from, yep, that's one of them. All codes should just be on one line. That's not a suggestion. Make card number, yep, lowercase. This is a suggestion. Add our semicolon at the end. Capitalize patrons. We don't need to capitalize our table. And then make select lowercase. Nope, that's just right as it is. Let's submit answer. It looks like we're good. Querying the books table. You're ready to practice writing your first SQL queries using the select and from keywords. Recall from the video that select is used to choose the fields that will be included in the result set, while from is used to pick the table in which the fields are listed. Feel free to explore the books in this exercise. Let's zoom in on the table in the database schema to see the fields and the data type it contains. Your task in this exercise is to practice selecting fields from books. So we scroll down to the instructions here and it says use SQL to return a result set of all the book titles included in the books table. So book titles is field called title. So let's go here, we'll say capital and select, and it's just title. From, and then our table is books, and end it with a semicolon. Let's run our code. Looks like we have a lot of titles here, so it looks like we pulled the right thing. Let's submit our answer and see if we're right. Looks like we're right on the first one. For our second question, it says select both title and author from the books. So we'll remove this, we'll add our title back here, a comma, and then author. And then let's run this. We can see that the author is popped up here on the query. So it looks good. We'll submit our answer. And that was correct as well. For question 3, it says select all fields from the book table. So pretty easy. We're just going to replace this with a star. Run our code. And we have the ID, title, author, year, and genre here. And you can see from our schema, the ID, title, author, genre, and published year are all available, so this looks good. Let's submit answer, and we were right.
Sometimes it can be helpful to rename columns in our result set, whether for clarity or brevity. We can do this using aliasing. Perhaps we'd like to select the name and hire year for each record in the employees table. We could alias the name column as first name in the query by adding the as keyword to indicate an alias of first name after selecting the name field. The result set now has first name rather than name as the column header. The alias only applies to the result of this particular query. In other words, the field name in the employees table itself is still name rather than first name. Some SQL questions require a way to return a list of unique values. Let's imagine that we are interested in getting a list of years in which we hired our current employees. If we select the year hired field from the employees table, the result set shows several years listed twice, which isn't what we are looking for. To get a list of years with no repeat values, we can add the distinct keyword before the year hired field name in the select statement. Now, we can see that all of our employees were hired in just 4 different years. It's possible to return the unique combinations of multiple field values by listing multiple fields after the distinct keyword. Take a look at the employees table. Perhaps we'd like to know the years that different departments hired employees. We could use this SQL query to look at this information, selecting the Dept ID and year hired from the employees table. Looking at the results, we see that Department 3 hired 2 employees in 2021. To avoid repeating this information, we could add the distinct keyword before the fields to select. Notice that the department ID and year hired fields still have repeat values individually, but none of the records are the same. They are all unique combinations of the 2 fields. Finally, let's discuss saving SQL result sets. In SQL, a view refers to a table that is the result of a saved SQL select statement. Views are considered virtual tables, which means that the data a view contains is not generally stored in the database. Rather, it is the query code that is stored for future use. A benefit of this is that whenever the view is accessed, it automatically updates the query results to account for any updates to the underlying database. To create a view, we'll add a line of code before the select statement, create view, then the name we'd like for the new view, then the as keyword to assign the results of the query to the new view name. Here, we create a view called Employee Hire Years by assigning the results of a query selecting 3 fields from the Employees table to a new view. There is no result set when creating a view. Once a view is created, however, we can query it just as we would a normal table by selecting from the view. Time to practice refining and saving queries with these new keywords.
Making queries distinct. You've learned that the distinct keyword can be used to return unique values in a field. In this exercise, you'll use this understanding to find out more about the books table. There are 350 books in the books table, representing all the books that our local library has available for checkout. But how many of these different authors are represented in the 350 books? The answer is surely less than 350. For example, J.K. Rowling wrote all 7 Harry Potter books. So if our library has all Harry Potter books, 7 books will be written by J.K. Rowling. There are likely many more repeat authors. For our first instructions, it says write SQL code that returns a result set with just one column listing the unique authors in the books table. Enter here, select, let's type in distinct author, and then we'll say from books table and end it with a semicolon. Let's run our code. So author unique 247 rows, looks like our count. Let's submit this answer. Looks like we were correct. So for our second instruction, it says update the code to return the unique author, which we already did, and genre. So it looks like we're adding genre combinations in books table. Selects distinct author and then genre, and then we have from books already. Let's return our code. So we added the genre here. Let's submit our answer and see if this is right. Looks good. Aliasing. While the default column names in the SQL result set come from the fields they are created from, you've learned that aliasing can be used to rename these result set columns. This can be helpful for clarifying the intent or contents of the column. Your task in this exercise is to incorporate an alias into one of the SQL queries that you worked with in the previous exercise. So our instructions are to add an alias to the SQL query to rename author to unique author in the column set. So let's do as unique underscore author. And that looks good. Let's run our code and make sure it works. A new title here, submit our answer. And that was it. Viewing your query. You've worked hard to create the below SQL query. What if you'd like to be able to refer to it later or allow others to access and view the results? The best way to do this is by creating a view. Recall that a view is a virtual table. It's very similar to a real table, but rather than the data itself being stored, the query code is stored for later use. So our instructions say add a single line of code that saves the results of a written query as a view called library authors. So let's go ahead and highlight this, Control copy, replace this as create view, let's in parentheses name it as, I think that's it. Let's run our code. And nothing showed up, so let's submit an answer and see if we're right. Looks like that was correct. So the next instruction says check that the view is created by selecting all columns from library authors. So let's figure out how to do this, because when we created the view we weren't given a success message or anything, so this is pretty helpful. So let's do select all from, and paste our table name and end it with a semicolon, run code. Looks like everything's there, so let's submit our answer. Looks great. Continue.
SQL Server or Oracle database, which are used by many companies. All SQL flavors are used with table-based relational databases like the ones we've seen, and the vast majority of keywords are shared between them. In fact, all SQL flavors must follow universal standards set by the International Organization for Standards and the American National Standards Institute. Only additional features on top of these standards result in different SQL flavors. Let's take a look at two of the most popular SQL flavors. PostgreSQL is a free and open source relational database system which was originally created at the University of California, Berkeley, and was sponsored by America's famous Defense Advanced Research Projects Agency, or DARPA. DARPA also sponsored research leading to creating the internet, the computer mouse, and GPS. The name PostgreSQL is used to refer to both the database system itself as well as the SQL flavor used with it. SQL Server is also a relational database system that comes in both free and enterprise versions. It was created by Microsoft, so it pairs well with other Microsoft products. T-SQL is Microsoft's proprietary flavor of SQL used with SQL Server databases. Think of SQL flavors as dialects of the same language. If Claudia speaks American English, she will have no trouble understanding people on a trip to London, even though most people in London speak British English and there are some small differences. Here's an example of a small difference between SQL Server and PostgreSQL. When we want to limit the number of records returned, we use the limit keyword in PostgreSQL. Here, we limit the number of employee names and IDs selected to only the first two records. The exact same results are achieved in SQL Server using the top keyword instead of limit. Notice that this keyword is the only difference between the two queries. Limiting results is useful when testing code, since many result sets can have thousands of results. It's best to write and test code using just a few results before removing the limit for the final query. New SQL learners may wonder which flavor they should learn. This may be an easy decision if a learner knows that her employer uses Microsoft's SQL Server, for example, or it might be a hard one for a job seeker or student who doesn't know what database management system a future employer might use. Don't worry too much about what flavor to learn. As we've seen, the differences are small. A PostgreSQL wizard can become a SQL Server wizard by learning a handful of different keywords. Now that we've sampled a few SQL flavors, let's practice.
Comparing flavors. The video introduced several differences between SQL Server and Postgres. These are just two of many relational database systems available, but the differences are fairly representative of the types of differences you'll see between other SQL databases, systems, and flavors as well. Instructions: drag the statements to the database management system that is correctly describes. Alright, so created by Microsoft was SQL Server. Research funds provided by DARPA, I think was Postgres, as both free and enterprise was SQL Server. Free and open source is Postgres, developed by the University of California. I think this was Postgres, and actually DARPA was SQL. But let's see. Queried using T-SQL, I think is SQL Server. I'm not really confident, but let's see what we get. Submit answers. It was just the DARPA one. Submit answer. Yep, got it right. Let's click continue here. Limiting results. Let's take a look at a few of the genres represented in our libraries book. Recall that limiting results is useful when testing code since result sets can have thousands of results. Queries are often limited with a limit of just a few records to test out code before selecting thousands of results from the database. Let's practice with the limit. So the instructions. Using Postgres SQL, select the genre field from the books table. Limit the number of results to 10. So let's go select, and we want to pull the genre field from books, and then we'll put a limit of 10 into a semicolon, making sure that our labels are undercase as well as our table, and then our actions or select from limit are all uppercase. Let's run our code. Looks like we have 10 out of 10, so it looks like it's running right. We'll submit our answer. And it was correct. Continue. Translating between flavors. In the previous exercise, you wrote the following code using Postgres SQL. This database in the course is a Postgres SQL database, so you won't be able to run SQL Server code in any of the exercises. What if you did want to update the above query to work with SQL Server though? How would you do that? So it looks like I think just replacing limit with top, correct? Everything should run. Let's submit answer. And that was it. It looks like that might have been the conclusion to our course, seeing the congratulations screen, but let's watch the video and find out.
You did it! Congratulations on completing this course. You've now got a strong understanding of the foundations of SQL. You've learned when and why databases are useful. You've navigated the organization of relational databases, and you've written your own SQL queries to extract insight from a database. From here, it's only a matter of learning more keywords before you're writing complex SQL queries. As we discussed, the keywords you learned in this course are shared between SQL flavors, and that is true of most keywords. However, given the small differences between flavors, the next course you take will be specific to a SQL flavor. Here are a few Datacamp courses that you may want to take next. No matter where you take your new SQL knowledge, thanks for taking this course all the way to the end. And congratulations again on a successful start to your SQL journey.
So it looks like that concludes our course for the Introduction to SQL from Datacamp. I thought it was a pretty good course, a lot of information provided. My only feedback is I think there could have been a lot more exercises involved. It seems like they were pretty limited. I think we had a couple multiple choice questions about code, and then a few actual exercises where we wrote code. I would have liked to see a lot more of that, is my main feedback for the course. So if I do go back to the website, I do see they have practice here, which is kind of what I was looking for in the course, and one specifically to Introduction to SQL. So if I click into this, I see we get 5 challenges correct, no time limits, earn XP. So looks like this is kind of what I was looking for. Thank you for following along to the Introduction to SQL course hosted by Datacamp. If you enjoyed the content, please be sure to leave a like on the video and consider subscribing. Thank you.